So now, so in the previous class, we talked about cloning. Like why do we need to do cloning, and what is the mechanism to do the cloning? So let me briefly recap that, and then answer the question all that you had, which is about super.clone. Okay, so clone, as the name indicates. So if you want to have the exact replica of an existing instance or an object, then it's called cloning. You need to do the cloning to get the same state as the other object, meaning the same values of the instance variables, but it should be a different copy. It should not be the same copy. So the good practice is we had this, I think, somewhere right at this one. So these three are considered to be good practice. So so like its state is not absolutely required, but if you can ensure these three happen, then it's good. So the first one is the clone of X. So X here is an instance that you want to clone. So the clone of this instance should not be the same as the original, right? So they should be different. So they should be different in a sense. The references should be different. It should not be the same. Then both of them should be equal. So this assumes that you are overriding equals method in this particular class. Right? So when you do the equals, generally you compare the state of these two instances. Right? So the state should be the same. So in that sense, both of them should be equal, the clone and the original. And the third one is the type. So the type of the clone and the type of the original should be the same. So that means the get class for both of them should be the same.
Excuse me, sir.
Yes.
So I had a doubt regarding this get class method. So even in so this is like a general doubt in polymorphism. So let's say for an interface, so we can do something like in racer exam. Sorry, like the transportation example. I guess. So racer X is equal like transport X is equal to new car. Transport X is equal to new bike. We can do we can do that, right?
Mm-hmm.
So
Yes,
in that case, so now if I have to identify, like further down the line, if I have to identify like what is X, like is it a bike object or is it a racer object? Is it a bike object or is it a car object? So how do I do that? Do I do that also with get class only?
yes, in that, okay. Even there you can do the get class because X here is a pointer to the instance of bike or car. Right? So in that case, it should return either bike or car.
So would it return? Would it return a string of bike or car?
No, get class is of type class. So there's something called the capital C class, like the second half of this. But if you print it, then the two string will get invoked. So it will print the string equivalent of the class name.
Okay, so like let's say if I write transport X is equal to new bike, and then if I write X dot get class, it will return X dot, if I write X dot get class dot to string, it will return a string called bike.
Right, yeah, it should do that. That is what I expect.
Okay. So even though X is actually an interface object, kind like not an interface object, but it is like used through an interface, transport X is equal to new car, it would return me car. Car, like the dot get class would return me a car, right?
It should, because see, get class, as we discussed earlier, it's a method that comes by default from object, and only classes inherit from object. Interfaces don't inherit. Right? So that's why I think it should return the type called bike rather than the interface.
So in a case where we are talking about inheritance, let's say bike and car inheriting transport, which is another class. Then if I write transport X is equal to new bike, then what will my dot get class show?
It also works there also. It gives the like instance, which instance you are creating.
So will it give me bike or transport?
Bike. I tried it in the assignment only. This is assignment.
Hmm.
Okay, okay.
Great.
Thank you so much.
So that's good. Thanks. Um, okay, so let's get back. So yeah, these are the three things that are, like I said, it's a good practice, and you should make sure that these three happen. Right? So, and the way it happens is by doing it, by doing the cloning in a proper way. So let's come to that, but do observe this one. So you have this is how it's declared in the object class, which is the parent for all, right? For all classes. So the return type, sorry, the return type is object, and the visibility modifier here is protected. But whenever, okay, so just remember this one, and then we'll come back to this again when we override clone. Okay, so we went over these things. Let me get to here. Um, so when you want to override clone and implement clone in a proper way, so first step is to implement this interface called clonable. So this is an empty interface. It doesn't have any methods like we discussed earlier, and that's why it's called a marker interface. It's just it just says that point is now eligible for getting cloned. So that's what it indicates, and it has two instance variables. But the main thing to observe here is we are overriding, so there should be an override annotation here. But so we'll be overriding clone. And the third step here, so first step is this implements clonable interface. Second is you override clone. And third is you need to call the super.clone. So while overriding clone, you change this return type. So earlier in the object class, the return type was object, but you changed it to point, and you also modified the visibility modifier to public. But anyone even outside of this package and classes that are not subclass of point can also call clone. So this is allowed. So you can always go higher in terms of the visibility modifier, but you cannot go lower. So for example, if it was declared as public, you cannot go lower than public. Like you cannot make it protected or private. So this is okay. And now coming to this one. So um, in the original class, which is object, the return type was object, right? Now you are changing the return type to point, and you are still overriding it. So this is considered okay, starting from say Java 5, Java 5 and beyond, I think. So before Java 5, this was not allowed. So this is what is called as covariant return type. So okay, it's not mentioned here, but you can.
So like in every interface, we can do that. Like we can't change the number of passing arguments, but we can change the return type.
But
While
there's a restriction. I'll come to that. No. So yeah, you can change the return type, but this return type has to be only a subclass of the original return type. So in this case, the
okay,
original return type is object, and point by default is a subclass of object, right? So that's why it works. But if it is not a subclass or a subtype, so to say, subtype of the original type, then it doesn't work. So that's why it's called a. So there are these terms. So there is something called invariant and a covariant and a variant. So invariant means it's a constant. You cannot change the state or so. For example, if you have something called a class invariant, and you made one of these variables as static final, for example, like ID is public static final. So static final means you cannot now change it, and all the classes, or sorry, all the instances now should stick to the same constant, so to say. They need to abide by that. Right? None of the instances can change it. So that is the invariant, meaning it cannot be changed. Then you have the variant, so which is like a variable. Anyone can change it, and it is okay. Covariant is a mix. So you can change it, but with a few restrictions. And here the return type is a covariant, and you can change it, but the restriction is that it should be a subtype of the original return type. So in that sense, yeah, here it is okay to do this. You can change the visibility modifier as well as the return type.
So if I don't implement clonable, can I still call super.clone if I don't implement clonable? In some other method, can I still call
No,
super.clone?
so clonable, it will throw the. So yeah, I was coming to the explanation of this. Uh, so you need to implement this try and catch precisely for that reason. So if you don't implement clonable, it is going to throw the clone not supported exception if you call super.clone. But if you implement clonable, then this exception will never be thrown, and that's why this comment was added that this will never happen. So it doesn't matter even if you return null.
Okay, okay, thank you so much.
So does object implement a clonable? Like we are calling the super.clone, right? So we are concerned with the object.
Hmm.
So it might throw the clone not supported exception. So in this case,
No, no. If
this
you call
try and catch.
super.clone,
Yes.
if you sorry, if you call super.clone and the super in this case an object, it will never throw a clonable not supported exception unless you didn't implement clonable.
But sir, object does not implement clonable, right? So it can throw.
No object. Okay, so the only case when object when this call results in clone not supported exception is when this class, in the sense its point, does not implement clonable. In any other case, it doesn't. So if you implement clonable, then it does not throw it.
Okay.
So
Yeah.
so is that the only case when I get a clone not supported exception?
Yes. Yes. So yeah, as far as I know, so if you don't implement this clonable interface, then it will throw it.
Okay, thank you, sir.
Okay. So now, yeah, let's discuss about the super.clone, which is yeah. Yeah, thanks. So there seems to be some hidden things. Okay. Hopefully you are able to hear my voice because I got a message that my internet connection is not great. Okay. So yeah, there are multiple steps or at least couple of steps that happen under whenever you call this, whenever you make this call, right? Super.flow. So the first step, so again, all these steps are not intuitive as such if you look at this call, but these are the steps that happen, right? And I can give you some references for that, but let me go over the steps. So first is here super refers to object, and whenever you call this first thing that it will check is whether whatever object on which you are calling it. So here, so here it was the point class, right? So first thing it will check is whether point class is implementing clonable interface or not. So if it does, it's okay. If it doesn't, it will throw this exception. So in this case, it has implemented the clonable interface, right? So then it will proceed to the next step, which is to create an instance of this point class. So it will create a new instance, and then that's the second step. And the third step is it will start doing the for each instance variable of the point class, it will do the assignment operator. So it will make use of the assignment operator to say that okay, now you need to um, uh, make a copy of it. I don't know if that was okay. So it's not, I guess, clear from. So whenever we call it, where do we call it? Okay, so here, okay, so we implemented clone, which is just one statement, super.clone. And now I'm creating two instances. So one, I created the first instance, which is T1, and then I call the constructor. Right? So this test clone class has two variables, instance variables. One is ID and the other one is name. And I want to say that T2 should be a clone of T1. So I said T1.clone. So now whichever object has called clone, um, so it will check the type of that class of that instance. So here it will check the type of T1, and if T1 has not implemented clonable, it will throw the exception. If it has implemented, it will proceed to the next step. So the next step would be to create an instance of type T1. So in this case, it's test clone. So it will create the type of T1, so test clone. It will create the instance, and then it will start copying the individual instance variables one after the other using the assignment operator. Right. So for example, here in this case, there are two, ID and name. So it will say T2 dot ID equals T1 dot ID, right, just for the sake of explanation. And then it will say T2 dot name equals assignment operator equals T1 dot name. After that, it will return the super. Since it's supposed to return objects, it has to return object, but it's actually an instance of point. Right? So it's something like so object P is new point, and then it will return P. Right. So that's why it's okay to typecast it to back to the point. Yes, so those are all the steps that happen behind this. So this is not very intuitive, but okay, let us look at this. So I got some. So this is a good reference, which is the Javadoc. It's publicly available, and you can take a look at the Javadoc for the clone, right? So it's so whatever I explained here is part of this one. It's already mentioned here. So the other nice reference that I got is this one, which I can share it with you. So is that clear so far? Or do you have any questions?
Sir, suppose our class implement an array list or like an array. So
Right.
will
So I'll come to the other cases, but this is what. So we'll be discussing this case in the next few slides.
okay.
So so as long as your data types are primitive data types, right? So this is okay, or this is what results in what we call a shallow copying. So for example, and shallow copying works for primitive data types, like as long as it's a int, float, or double and string, so it's okay. You can do the shallow copying. But we'll come to the definition of shallow copying and other deep copying in a few seconds or a few minutes. So, so I'll just repeat the steps that happen with the super.clone. So the first step would be to check the type of the callers, right? So for example, if here it's T1.clone, so it will check the type of T1, which is test clone. So the first thing that it will do is whether test clone has implemented clonable interface or not. So if it has implemented, then it's okay. If it doesn't, then it will throw a exception, which is the clone not supported exception. So that's the first step. Second step is it will create a new instance of type test clone. So it will create a new instance of type test clone. Let's say that's of type. Let's say we can call it as TT, for example, or TC. And the third step would be to make these assignments. So it will say tc.id equals t1.id. So it already knows that t1 has made the call. So the new clone should be the same as t1 in terms of the state. So it will start making the assignment operator copy. Right? So it will say tc.id equals t1.id and tc.name equals t1. And then it will return that newly created instance. Right? So those are the steps that take place here. Yeah, and that's why super.clone works, right? So okay, so are there any questions? So you can also, like I said, go over the Javadoc, which is pretty clear. So it also talks about these steps. And if you think it's helpful, I can also share this particular reference, which is the Java Revisited blog. So it's a 3-part series on cloning, and I found it to be useful. Okay. So shall I move on? Okay, so these are, sorry, yeah, one more point. So if at all you are subclassing the type that where you implemented clonable, then in your subclass also you should override clone and change the return type. So in the subclass it should return the type of that particular class, which is point3 and not point, right? And you again do the super.clone. Okay, so yeah, those are the and in a subclass you don't need to use try and catch, because it's only the object class that checks for whether the point, for example, has implemented clonable or not. So no other parent would be checking it. So it's okay. So if you implement point, say if you implement clonable by point, for example, and since you are inheriting it automatically, this class is also marked with the same interface, which is clonable. So you don't have to you don't have to use try and catch block inside the subclass. Okay, so those are the points related to the implementation of clone. So let's go ahead with the question that was asked. So which is about the shallow copying and deep copying, right? So here's an example. So let's say one of the instance variables of this class is not a primitive data type, and it's a reference here. So it's a type of list. So we'll get to know what we mean by when we use these angular brackets and the type inside, right? So that's the topic. That's the next topic. So it's called generic programming, and we'll be discussing that in the next class or in this class after some time. But just assume that this is a list of strings. So that's what this means. So every element that is part of this list should be of type string. So now you have a list and it's not a primitive type. And so list is a class. So list is a class, and this is a instance variable of type list, right? So this is very similar to your car, for example. So you are saying car C. So in the same way, you are here saying that transactions is of type list, and list is a class. So if you have non-primitive data types, then just using super.clone would be an issue. And we'll just see what the issue is, right? So, okay. So there are two types of copying. One is the shallow copy and the other one is the deep copy. So if you just use super.clone, and if there are non-primitive data types, it will return in what is called a shallow copy. So what happens here is, so let's say you have your simple primitive data types, which is int and double, and there are values for it, 42 and 3.14. So if it is primitive data types, it will make duplicates of it, and it's okay. Because like I said earlier, the way it creates these duplicates is by the assignment operator, right? So it will simply say say let's say clone dot x equals original dot x, and clone dot y equals original dot y. And in the same way, it will say clone dot in equals scanner dot in, and clone dot data equals original dot data. Right? So it will make these assignments. So if you do that, then for the last two cases, it will be copying the reference, right? So when you say point P1 equals P2, where P2 is also a point, is an instance variable of type point, then you are copying the reference and not the state of the object, right? So now P1 and point P2 would point to the same memory location. So the same thing is happening here. So you have in and data, which are non-primitive data types, and using clone, you made a copy, but it has copied the reference and not the value. And you wanted, so the disadvantage in this case is, let's say you change the list in the clone, then the original list would also get changed, which is not perhaps what you wanted, right? So they both are now pointing to the same memory location here. So that's the issue with the shallow copy. So now if you want to fix that, so let's say you want to make a full copy, but if you make changes to the clone of say the list of the clone, then the original list should not get changed. So in that case, we have to do a, what is called as deep copy, and this is what you ideally want, right? So in and data point a memory location, and they have some values associated with them. So these are the memory locations, and then the values associated with them, right? So now you want to have the two different memory locations, but with the same values. So let's say list has 3 elements, 1, 2, and 3. So even the clone should have the same values for the list, which is 1, 2, and 3, but it should be pointing to a new memory location or a different memory location. So that is what is referred to as deep copy. So you copy the entire reference graph. So this is known as the reference graph. It is called a graph because array lists can again have elements which are non-primitive data types, right? So there can be an array list of employees, for example. So again, each array element is a type of employee, and again within the employee there can be one more non-primitive data type. Let's say address, for example. So address can be a mix of street name, pin code, and so on. So it's a complex data type or a user-defined data type. So there can be a reference to a reference, and that can further have references. So if you copy the entire reference graph, that is what is called as deep copy. If you do a simple assignment, then you are simply copying the reference and not the values. Right? So in that case, it's called a shallow copy. And if you use simple super dot clone, it will do a shallow copy, which you want to avoid. Right? So are there any questions so far? Okay, so let me move on. Let's see how to create these deep copies, right? So here, yeah, you want to create a clone of, or you want to say that you can create a clone of the bank account. So you implemented clonable, you have overridden clone, and you also called super.clone. Now, but the issue here is it has a non-primitive data type, which is transaction, which is a list, right? So you want to create a new copy of it. First is create a new memory location and then copy the values, right? So you have to call the constructors because you have to create a new memory location, right? So that's why you call the constructor, which is the new array list. And then you pass in the transactions, which is the original one. So this will create a new instance, but copy the values of the original list elements into this. And now you can return this copy, which is the clone. So you have to do it at every step, right? So for example, transactions, like I said, it's a list of employees, and employee has, again, one of the instance variables is address. So you have to make sure that all the nodes in this reference graph are copied and not copied within a new memory location. So if you can ensure that, then you can do this. Then you have performed the deep copying, and which is what should be done within the clone method. So